This is Dr. J. Nitya, Professor in the Department of Information Technology, K.S.Rangasamy College of Technology. The topic for discussion is combinational logic circuits. So the logic circuits for the digital systems can be either combinational or sequential. Any combinational circuit will be consisting of logic gates where the output at any instant of time are determined from only the present combination of the inputs. So these combinational circuits will perform an operation which can be specified by means of a Boolean functions. So you will have a circuit by using only the logic gates where the output at the any instant is determined based on the combination of the inputs whatever you are giving. So this slide shows the block diagram of a combination circuit where we have n inputs and m outputs. So any number of inputs can be given and any number of outputs can be taken. So this behavior of the combination circuit is specified by a truth table which lists the output values for each combination of the input variables. So if you have n inputs, we will be having 2 power n different combinations and which will be defined by m Boolean functions one for each output variable. Okay, so this slide will tell us how to form a Boolean function from a logical diagram. So you will be provided a logical diagram. From the logical diagram, label all your gate outputs. How many outputs you have, that all the gate outputs has to be labeled, which are the function of the input variable. Suppose if you have an AND gate, label it by the corresponding AND function. Suppose if the inputs of the AND gate are A and B, label the output as A dot B. If it is an OR gate, label it as A plus B. Likewise, determine the Boolean function for all your gate outputs. So proceed it by stage and finally form a Boolean expression for the output variable. So consider this is your logic circuit. Here we have different AND gates and OR gates. So form the expressions for the expressions for T2, T1 and then proceeded for finding the final expression F1. Similarly, here form the expression for F2 and then proceeded for finding the final expression F1. So here we have 3 binary inputs A, B and C and 2 binary outputs F1 and F2. So when we say F2, so this is here F2, which is obtained by these 3 AND gates and an OR gate. So these 3 AND gates are AB plus AC plus BC. So that is F2. This is F2. And in case of F1, it is a temporary output variables T2, T1, both are given as an input for this F1. So T2, T1, where T1 is given for this AND gate. So here we have an expression T3 which is equal to T1 and F2 bar. So T3 is equal to T1 dot F2 bar and then this is OR with T2. So F1 is equal to T2 plus T1 F2 bar. Likewise form the expression and form the final Boolean expression. Then how a truth table is formed from the logical diagram. So determine how many output variables you have, that has to be listed, and first initially determine how many input variables you have. Depend upon the number of input variables, list out all the different combinations. So here we have 3 input variables A, B, C. List out all possible combinations. So 3 means 2 power 3, it's 8 combinations listed out. And then form the expression for F2. We have formed the expression already, F2, AB plus AC plus BC, form F2. And then we need T1, T2, T3 and F2 bar for finding out F1. So find out all it and then form the expression for, that is form the truth table for F1. Now this is the main. So how to design a combination circuit? So for designing a combination circuit, there are 5 stages. First one, you have to specify the design objective, that is for what purpose we are going to design this combination circuit. That has to be defined. And then determine how many number of inputs you have and how many outputs we have. So that has to be determined. And third stage is assign the symbol for each input and output. And after that, depend upon the specification of the objective, you have to derive the truth table that defines the relation between input and the output. Finally, using either Boolean function or that is Boolean algebra, or by using the truth table K-map simplification, find the simplified expression. Then for the simplified expression, we have to draw the logical diagram. So here I have taken a simple design. Design a combination circuit with 3 inputs and 1 output. The output is 1 when the binary value of the input is less than 3. The output is 0 otherwise. So here we have 3 variables x, y, z and 1 output f. The output is equal to 1 when the input value is less than 3. So we have 3 variables input as we mean have 2 power 3 8 combination 0 to 7. When it is lesser than 3, that is for 0, 1, 2 combination, the output is 1. For 4, 5, 6, 7, the output is 0. So first one, specify the objective, find the input and output variables, list it down, then form the truth table. After forming a truth table, represent in a K-map. So we represent the truth table in the K-map, solve the K-map, we will get a pair, 2 pairs are formed. The expressions are x bar, y bar plus x bar, z bar. So for the formed expression, we have to draw the logical diagram. This is x bar, y bar on AND gate, and then x bar, z bar, and finally it is given for an OR gate. So this is the way in which a combination circuit can be designed. Similarly, we will take for the design of another combination circuit. When the binary input is, that is this circuit is also with 3 inputs. Here when the binary input is 0, 1, 2, 3, the output should be 1 greater than the input. And if the binary input is 4, 5, 6, 7, the binary output is 1 less than the input. So we have x, y, z. So as usual we have 2 power 3 8 combinations. These are all the inputs. X, y, z are the input variables. A, B, C are the output variable. So list out the input variable and output variable in a truth table. For 0, 1, 2, 3 combination, the output is 1 greater than the input. So for 0, output is 1, 1, 2, 2, 3, 4, 5. And then 4, 5, 6, 7, the output is for 4, it is 1 less than the input. So for 4, it is 3, 5, output is 4, 6, output is 5, 7, the output is 6. Then as usual, since we have 3 output variables, draw 3 K-maps, one for A, B and C. So form the expressions. So here we have 3 pairs. So expression is xz plus xy plus yz. And this no grouping is formed. So x bar y bar z plus x bar y z bar plus x y bar z bar plus x y z. Finally we have a quad here. These 2 ones and these 2 ones can be grouped. And finally we got an expression as C is equal to z bar. For the formed expression we can represent using a logical diagram. Thank you.